I'm going to make the ultimate cheat sheet for orbit problems.
Right now?
Yeah, let's do it. Right? So let's go. Our first orbit condition is mass of the central body, mass of the satellite over r squared. Right? Okay. And these guys, this guy always cancels.
Are you
Right?
recording?
Yeah, am I? I am recording. There we go. This guy always cancels. We can always cancel an r. Right? And then we can solve this for v. V is just going to be, well, by the time you get v, it's just the square root of this, right? Right? And literally, when you type it into your calculator, it's going to look like square root left parenthesis 6.67 e minus 11 times, you got to say times, right? The mass divided by radius. And you'll have to substitute the numbers in for that. And then we can also solve this for the central body mass. Right? So the mass of the central body is it's going to be v squared r over g. Right? And literally that'll be whatever the velocity is squared times radius. Right? Divided by 6.67 e minus 11. It's always that constant's always the same thing. And then we could solve it for r. R is going to be g mass of the central body divided by v squared. Is that right? Seems like it's right. Yeah, check my answers. Make sure I don't make mistakes. Somebody have these from their notes? Are these all the way they... I'm sure of this one. I'm pretty sure of this one. Is that one right?
Yes.
Yeah, okay. You don't know? Are they right? Okay. And then this guy's just going to be 6.67 e minus 11 times the mass divided by velocity squared, right? The exciting other one is that g mass of the central body, mass of the satellite over r squared is mass of the satellite 4. Yeah? Okay. And in this case, the only thing that cancels to begin with is the mass of the satellite. And so if we are solving for the central body mass, that might be the easiest one, right? That's going to be g 4 pi squared. Whoops, that's not right. 4 pi squared r to the third divided by t squared g. Is that right? Connor, where's my check? Is somebody checking these? You got it? Are you checking? Is that right? Thank you. Okay. Literally on your calculator, it's going to look like 4 pi squared times, and then you have to say radius, caret 3. You can also, there's a math thing that does that, right? Divided by period. And then you have to, when you do this, the denominator, since there's two things, you got to put parentheses around it. So divided by parentheses, period squared times 6.67 e minus 11, right parenthesis for this guy, and that's it. Right? And then if we wanted to solve for r, r is going to equal, it's going to be a cube root, right? And it's going to be the cube root of, well, it's going to be gmc t squared, right? Because that guy's going to go up there, and then it's going to be divided by 4 pi squared. Is that right? Is that one right? We got that? Okay. Good enough. So this is going to be, to do this, you're going to need to find the cube root. It's in the math thing. So if you go math something, it's in there, right? Okay, or you can just put it in parentheses and raise it to the 1/3, right? So it's going to be cube root, left parenthesis, 6.67 e minus 11 times mass times period squared, right? And then you have to go divided by parenthesis 4 times pi squared, parenthesis for that, another parenthesis for this, right? And then the final one is period, and period is going to be square root of, right? And the t-squared goes up there, these guys go down there, and so we have 4 pi squared r to the 3rd over GMC. Yeah? And you can take the 2 pi out, yeah. Right? So ultimately it becomes 2 pi r to the 3rd over g. Yeah? And then when you type that into your calculator, it's going to look like 2 pi square root left paren radius divided by 6.67. And these have to be in parentheses. So divided by parentheses 6.67 e minus 11 times mass. Remember, it's the central body's mass, not the satellite's mass. So on the one where I give you like the moon and the planet, the most common mistake is people use the moon's mass. Yeah? Oh, all right.